So I've got this curve,
Yes?
and I want to find the area underneath it,
Why would you want to do that?
because Mr. Breeze assigned me some homework.
This was gonna be due on Monday, but Mrs. McDonald said it should be due on Friday.
That's a good reason. Here's how you do it. Wait, how accurate do you want to be?
Well, I only need an approximation for now.
You could just use the height at your starting value and multiply that by the interval you want to approximate the area over.
It seems to me that's not very accurate.
We are the Integral Ninjas, and we are outraged by your inaccuracy.
Why? Because you're ninjas?
No, because we believe in using integrals to find the area under the curve, so that we not only have an approximation, but the truth you seek. Now we shall battle you for your disgrace of calculus.
Yay! Laziness wins again!
For reals, Holmes. But seriously, if you want to obtain a more accurate approximation of the area, you could divide your interval into two portions using the height at the beginning point to find the area of each rectangle. In fact, you will continue to gain a more accurate approximation as you divide the interval into smaller portions. This method for approximation with rectangles is called a Riemann sum. With Riemann sums, you can use the left endpoint, the right endpoint, or the midpoint as the height of each rectangle.
How would you rate that formula?
Like this.
I see. C initial is a point, just like a midpoint or right endpoint within the ith subdivision, and the delta x is an interval divided by the number of subdivisions b minus a.
Right.
What if you love geometry?
What? Love geometry? Boys, you crazy?
Well, it seems to me you could use trapezoids instead of rectangles to find the Riemann sum.
I guess you could.
Yes, one would use the formula a equals h times sum of b1 plus b2 divided by 2, where h is your delta x, b1 is the height at the start, and b2 is the height at the end point. Also, you could divide the interval and add up all of the trapezoids using the formula b minus a over 2n times sum y initial plus 2y1 plus etc. plus 2yn minus 1 plus yn. End bracket.
That's how you approximate the area under a curve.